All right, today we're going deep. We're diving into the very heart of our computers, the operating system kernel, to look at a brand new tool that is finding critical security bugs where pretty much nobody else could even look. So I want you to think of your operating system's kernel as this ultimate guardian, right? It's the bouncer, the security guard, the final authority on everything your computer does. It's supposed to be impenetrable. But what if that guardian has a massive, and I mean massive, blind spot? And that's exactly where we're going to start. Because to really get why this new tool is such a breakthrough, you first have to understand the sheer scale of the problem it's trying to solve. Okay, so at the very center of it all, you have the kernel. But it's not working alone, not even close. To talk to your graphics card, your Wi-Fi, your keyboard, it needs help. And that help comes from thousands of little programs called drivers, written by hundreds of different companies all over the world. Now, here's the crazy part. These drivers don't just run alongside the kernel, they become a part of it. We're talking about a gigantic amount of code that gets plugged right into the most sensitive part of your computer. And a lot of the time, it just doesn't get the same intense security check that the main kernel code does. And look, don't just take my word for it. A report from Google puts it bluntly, most of the bugs found in the kernel, they're in the drivers. This right here is the kernel's giant blind spot. And a single bug in just one of these drivers, well, that can bring down your whole system. So you might be asking, how do the good guys find these bugs? Well, their number one weapon is a technique called fuzzing, but lately it's hit a major wall. Fuzzing, at its core, is a brilliantly simple idea. You just throw a whole bunch of random, nonsensical data at a program and see if it breaks. It's basically automated chaos engineering. You're trying to find those weird edge cases that a human tester might never think of. And believe me, it works. The undisputed champion of kernel fuzzing is a tool from Google called Syzkaller. It has found thousands of bugs in Linux this way. But for all its power, it has one critical weakness. See, the problem with random data is that it's random. It's like trying to get into an exclusive club by just yelling random words at the bouncer. What happens when what you really need is a secret handshake? The fuzzer is just stuck outside, completely unable to test what's going on inside. Now, in the programming world, this secret handshake is called an explicit dependency. It's a two-step process. One command, we'll call it the producer, has to run first. It does something and gives you back a special key or a handler. Only then can a second command, the consumer, use that exact key to do its job. And this is why our fuzzer fails so badly. It tries to use that second command, the read command, but for the key, it just plugs in a random number. The kernel takes one look at that and says, nope, I have no idea what you're talking about. Error. The fuzzer never gets through the door. The real secret handshake looks more like this. First, a program has to call open. That's the producer. The kernel then gives it back a valid key, like handle number 3. Then and only then can the program call read using that specific handle. And boom, success. A random fuzzer would almost never guess that sequence. So, that's the big puzzle, right? How can you teach a fuzzer to learn all these secret handshakes all by itself? Well, this is where the genius idea behind SyzGen++ comes into play. This really is the million-dollar question in this field. If you could crack this, you could suddenly test huge parts of the kernel that have been effectively invisible until now. The researchers who built SyzGen++ had this amazing insight. They realized these dependencies almost always follow a simple pattern, insertion and lookup. The best way to think about it is like a digital code check. The first command, the producer, takes your code, inserts it into storage, and gives you back a ticket. That ticket is your handler. Then, the second command, the consumer, uses that exact ticket to look up and get your specific code back. By just looking for this pattern, the tool can start to figure out the secret handshakes. Okay, so that's the big idea, the code check pattern. Now, let's see how they actually build a tool that can find these things automatically. This is it, SyzGen++, and here's its superpower. It is the very first tool that can figure out all these dependencies without ever needing to look at the source code and without needing any example tests to learn from. It just analyzes the final compiled code directly. And if we compare it to the other big players, you can really see why that's such a huge deal. Other tools, like Diffuse, need the source code. Tools like Moonshine need existing test logs or traces to analyze. SyzGen++ needs neither. And that, my friends, is a total game changer. It means you can finally analyze all those closed-source drivers from companies like NVIDIA or Broadcom, code that has, until now, basically been a black box to security researchers.
So, the theory is awesome. The approach is brilliant. But does it actually, work? Does it find bugs in the real world? Oh yeah, big time.
First off, SyzGen++ found 245 more of these secret handshakes in Linux drivers than any of the previous automated methods. It's just flat out better at understanding how these drivers communicate. And because it learns those handshakes, it can get much deeper into the code. This chart shows us code coverage, basically how much of a driver the fuzzer was able to test. SyzGen++ got a whopping 71% more coverage than its rivals. It is reaching places inside these drivers that have probably never been fuzzed before. And what happens when you start testing code that nobody's ever tested before? You find bugs. SyzGen++ uncovered 10 brand new, previously unknown bugs. And this isn't in some dusty old piece of software. This is in the Linux 6.2 kernel, which is scrutinized by some of the best security minds on the planet. And here's the real kicker. 6 of those bugs were serious enough to be assigned official CVE numbers. That's the industry standard for a confirmed, recognized security vulnerability. This isn't just an academic success. This is a tool that is actively finding and helping fix critical security holes in software that runs the world. So SyzGen++ has effectively cracked the code, teaching us the secret handshakes needed to get into the hidden corners of the Linux kernel. And it really makes you wonder, if this is what it found in a system as open and heavily tested as Linux, what other secrets are still hiding in the countless drivers running on all of our other devices right now?